Okay. Hello and welcome to my foundation presentation. What I'm going to be going over first in the exercises is exercise about non-context free languages. It's 2.42 in the third edition of the book. Um, and so essentially non-context free languages come into play because we started with finite languages, which can be written in terms of DFAs, and then we found what was not included in there, and which were regular languages, and then moving a step farther than that, we found that context-free languages were not inside of regular languages. And now we're trying to find the relationship between context-free languages and all the languages, which is going to be anything that's not in context-free languages, thus non-context-free languages. So we're going to prove that similarly to the way that we prove that CFLs are not in regular languages through a pumping lemma. The last one had three parts, which introduced the X, Y, and Z, where Y was a repeating loop, where if any accepting string touched Y, it would proved an idea that there would be a loop and things could happen n amount of times, so it wouldn't have to be finite or regular. So now we're going to take that a step farther and do a new pumping lemma into 5 parts: U, X, Y, V, and Z. That was a terrible alphabet, but so that lemma is important because the second and fourth parts, V and Y, can happen any amount of times, and that string is still going to be in the acceptance string, which I'm going to show how that works. So on the left side, I have just a quick little diagram about T being our input string, which can then be broken up into U, R, and Z. So U and Z are 2 of our 5 pumped lengths, and then R is going to be broken up even farther into either this first path here, VRY, or into X. VRY has to happen at least once, or else we won't have 2 of our 5 parts. So VRY happens, and then after that it can be broken up into another VRY or X, and that shows the idea of a recursive aspect of our input string, and that's why V can go to the I and Y can go to the I, and X only happens once. So I do a few examples of that on the right side. I blew up 1 here on the left side, which is language 0 to the n, 1 to the n, 0 to the n, 1 to the n, where n is greater than 0, greater than or equal to 0. And this is going to be a non-context free language, and we're going to show why it can't be pumped. So I picked an arbitrary pumping length of 4. You could do a bunch of these. I think I did a few just to make sure that it couldn't actually be pumped. But so I'd take a pumping length of 4, which comes up 0 to the p, 1 to the p, 0 to the p, 1 to the p, so 0 to the 4th, and I write that out here. And this is not a way that you can pump this into 5 parts. I just wrote it it was a proof by contradiction, so you have to kind of exhaust a few methods. So you know that there's going to be the same amount of zeros and ones in V and Y, because looking at it, you know you're going to have to break this up into kind of 2 parts that can repeat any amount of times and still be in an input string. So the closest I could even get to that was 0011 being a V and 0011 being a Y, and the rest of it being U and X and Z. And that doesn't work because V and Y, the zeros and ones aren't even going to the pumping length. It's about half of that, and if I was to repeat V and Y, it wouldn't lengthen the values of V and Y into the pumping length. It would just do 2 zeros, 2 ones, 2 zeros, 2 ones. So it doesn't work. There was a bunch of other ways that I tried to break it up, but none of them work, which is why it is a non-context free language. And so I do a few more examples, and so this one, 0 to the end, pound, 0 to 2n, pound, 0 to 3n, pound. You can tell right there that the pound, there's 2 pound signs that happen once, so those are both going to be 2 parts of your 5-part pumping length. You're going to have a U and an X be equal to those pound signs, and then so you've got V, Y, and Z, and there's no way for you to have V to the I and Y to the I happen so that they're going to be the an accepting string, because there's not even a pound sign anyways, so you know you won't have a repeating input string with just any amount of zeros being able to be accepted. So that one's not a context free language either. I go on further. C was very similar to the first example, and D was also pretty similar to that with the pound signs. I don't want to spend too much time on it, so I left the work up, but I didn't go over it. And so I found non-context free languages to be a little bit difficult to prove because you had to do it via contradiction. But I thought it was a nice way to go over just how this R transition could be broken up into a recursive kind of way of having an input string. So I thought that was very helpful to be able to, once I was able to understand this diagram, it was a lot easier for me to do the pumping lemmas. And so that was a start to what comes next, which is Turing machines.